Okay, I just have before we get to the questions, maybe just have a review of some of the subfiling, just to remind people, subfiling is just a way to, it's a compromise between file per process and a single shared file. So we did some more investigation. So this is kind of what it looks like, the higher level. You have the IO concentrator, then you can write to no local storage into persist it to disk. You have an option to do either or both. So I was running, make it bigger. I was running the CGNS benchmark and I was writing one file per node. And this is on NCSA's new Delta machine. So I used 16 megabyte striping and I did it to no local storage. And it was a fixed size problem. So I ramped it up from 2 nodes all the way up to 64 nodes. And at the end, the file was a 100 gigabyte file. So the write times you can see for 2, they actually is not bad. So this is writing to no local storage. However, if you look at the bandwidth, it's not great because I think the amount of you see, the bandwidth theoretically should be writing to no local storage should be about 4 or 6 gigabytes per second. And so I'm at 64, only getting 8. So I'm not sure why I'm getting such slow performance on using the local storage, at least on Delta. On Frontier, it scales almost perfectly to no local storage. I mean, I think it was 4 gigabytes per second, and they have 2 NVMEs per node. So, but it doesn't write it in parallel. So when one's full, I asked them if one's full, then it goes on to the second one. So, and it was getting roughly 4 gigabytes per second, and it scales up. So, I mean, this scales up kind of nice, but at 64, theoretically, you should be getting over 200 gigabytes per second. Is what we expect, and this is much lower. So I think we still have to investigate some work there. I also tried, I think the big issue with subfiling though is if you're writing to local storage, how to efficiently get that back to either combine it into a single shared file, or even if copying from the no local storage back to Lustre, for example. It's not performing as I had hoped. And it's hard to hide that if it's performing poorly through the application. So it's hard to hide that in the background, even though you're doing the background. And then either using HDF5 fuse tool to combine in one HDF5 file, or just copying it from the no local storage.
You mean combining file, right? Putting together all
Yeah.
subfiles.
So I think that's where we have to concentrate on getting better performance out of that. But it depends. So I'm a little surprised that no local storage is not that great.
Have you tried to write directly to Lustre?
I've tried that. That's even worse.
Oh.
Yeah. But on Frontier, I think it's maybe just the way they have it configured. Because on Frontier, I was getting almost close to I was getting 4 terabytes per second, which is almost theoretically the theoretical max. Whereas I was getting, this is going to be in a paper, so I wasn't going to present it here, but it's in a paper that we have submitted for publication. So, but it was getting pretty good performance. But still, the fuse tool, I mean, if it costs as much to fuse the files back together as it did just writing to Lustre, that's a problem. So we were having that issue on Frontier, going from the local storage to.
And on Frontier, you're saying it's the same problem, it's too slow?
Yeah, it's pretty slow. Well, and I couldn't hide, even though I was, forking a process and then calling H5 fuse to do it in the background, it's still not hiding it all for some reason, even though it should have had time to hide it. So I'm not sure exactly if there's some kind of locking issue still. But So that's all I have to say about subfiling. Is there any, I guess, general questions, subfiling, or anything else, HPC?
So are you going to profile and find out why it is slow?
Yeah, the problem is I have an allocation on Frontier, and I used up a lot of the allocation doing the paper results. So I have to scale back a little bit my Frontier usage, and I'll probably just go back to Delta because it's not charged as much as Frontier. So
Mhm.
I still have to test on Orion too when it comes back up. But yeah, we plan to profile it. And we did introduce I don't think it's not going to be in this release, but Jordan added a new API that detects that tells you what node is doing the IO because there's no way to get that information um, without an API that tells what node is going to do the IO if you're not doing it. I mean, what process is going to do it. So I wanted to know what process was going to do the actual IO. So we added a new one that returns what process on that node is going to do the IO.
You
So,
mean
but that
rank?
didn't make it into this release, but we still have to make a use case for it before we introduce the API to do it.
You mean rank, right?
Rank, yeah, the rank,
Okay.
the processor ID.
Right.
Any other questions, issues people are having?
So, but striping, so what is the local storage there? It's not Lustre, right?
On Delta, it's Lustre.
On Delta.
Yeah, Delta, it's
Oh, it's
Lustre.
not.
On Frontier, it's Lustre.
So have you changed striping?
Yeah, 16 is usually is typically the best that we found. The problem with, for example, on Frontier is they have Lustre set up to be a file per process to get the best performance. So it worked well. So in this actually on Delta, it's using the progressive file layout. And I tried both setting them manually and using progressive file layout. It still didn't perform as very well. Whereas Frontier, if I do progressive file layout with subfiling, it was pretty good, right? Because it's doing essentially one file per process. Whereas if I set it manually, it doesn't perform as well. So their tuning of is much better, at least for subfiling. We also might look into using maybe MPI because right now the fusing of the files is using DD, and maybe that's not performing as it should in parallel. And so maybe using MPI where it can do maybe collective reads or reading into the file and writing it back into Lustre might be better. I don't know.
I think it's good to know. So it's not panacea. Turns out.
But in general, I mean, I don't know why, but no local storage is it's very fast. It scales up almost linearly
Mhm.
in general, usually. That's what we found for most systems, except for this one. I mean, it scales up, it just is not the right slope.
Have you tried to use Fuse in different way by copying subfiles to the system and then running Fuse on uh, parallel system or actually any other system?
No, but the copy is probably going to be expensive. I found it's not very fast going from no local storage to Lustre because it's still going to have to write up one file, Lustre. I guess you could do it in parallel. I haven't
Right.
tried it.
You can parallelize that and then run, so it will be kind of local.
Hmm. But so far I haven't been able to, I mean, I have not been able to get it to be as performant. Well, at least with when I was doing a GPU one, which was doing just basically all GPU work and then using the CPU to write the files. So there's only one process per node in that case. And it wasn't when I fused it, I mean, the time it took to both write the file and then fuse it back together was basically the time it would have taken just to write to Lester. So for
But
that,
Fuse is not parallel to, right?
I mean, you
When
can run it back, you can create as many threads as you want, but it's not parallel, no. I mean, it's all taken, it's not doing parallel writes within each node, but they're all doing it at the same time, theoretically.
you can concatenate in parallel because you can write to the place, allocate the whole file, and then write each subfile to its own place, right? In parallel.
Yeah, but it's striped, so it's interleaved in the
Oh,
file.
okay.
Yeah, that might hurt performance a little bit. It's not contiguous.
Okay.
Yeah, maybe the next I'll have more subfiling results. I mean, CGNS is different because all the ranks are involved. So they first have to aggregate it to the node, the one that's doing the IO, then that one node's doing it. Whereas the one that I was talking about before, where you do GPU, it's just one. There's no aggregation going on because it's copying from the node memory or the GPU memory to the CPU memory. Just having one rank copy that or write that data. So I mean, the aggregation's not, it's being done by the GPU to CPU. That's where you're aggregating it. Any other issues or questions in general? Well, I guess we might cut the meeting short then if there's no questions.
Yeah, thank you, Scott, so much. Next week it'll be Dana's week on the 1st of April, so we'll see everyone then.
Actually, I
All right.
have one
Thank you.
question
Oh,
for Dana.
So,
It is related to that metadata cache entry that is bigger than limited size. So what are it's like it's bad that production just does its thing because cache will adjust itself, but debug mode with a search just quits, right?
I fixed that.
So it will continue.
No, right now we just we throw an error, right? And we'll come back to it. We didn't close the issue.
Uh-huh.
We kicked it down, but we didn't have time to really investigate exactly what was going to happen.
Because there is no reason to issue the error. I talked to John, and he really put it there just to discover that there are cases where his hard limit that can be changed, and the library then has to be recompiled to discover if they exist, if it's enough. But really, there is no reason why it should fail. It mostly was for noticing that those issues exist. It will be very slow because it will adjust itself, I believe, to 64K and then start, trashing the cache all the time. It will
Right,
be
but we just didn't have time to investigate for this release. And if there's an assert there, I'm not just gonna delete the assert and just be like, oh, it's fine.
okay.
So I made it a real error now, right, in production, and then we left the issue there, and we'll address it in 114.5.
No, but in production, you should be using error. That's
Yeah,
what
it's a
I'm
real
saying.
error. Yeah,
Huh?
it's a real error that we
No,
turned
it's
it.
not. It's not an error. Cache will adjust itself. It will be able to read any size of metadata cache item. That's why I was concerned. It shouldn't be an error. As I said, he put it just assert into debug just to discover if those cases exist, but cache will adjust itself. And it will, performance will suffer. And if you really have application that works with a file that, with old file, especially where metadata item is really very big, it still will work. There's nothing
That's
wrong
fine.
with
I
it.
can pull it back out. Right, but we shouldn't have like stuff littering the cache just to see if maybe there's a problem in the future. I mean, that's not really a smart way of doing stuff.
We can discuss it on another, but yeah, be aware because it's not an error.
All right, I can take it out.
Okay.
Yeah.
All right.
Okay. Well, thanks for
you.
coming. Yeah.
Thank
Thank
you.
you.
All right, bye.
Bye.